So let's make a big trip from the Bolivian areas to the middle Volga region by Eldar Kurbanov, who is here, okay, and Oleg Vorobev.
Yes, Oleg is also here.
Cool.
Hello, everyone.
Fancy to have both authors here, who mapped 3 species in the middle Volga region. So let's see what are the main results of this study.
Okay. Hello, everyone. Again, today I would like to talk about 3 species classification with the use of Sentinel-2, which is quite important. For our region since it's heavily forested. And before we were using Landsat images, and nowadays when Sentinel comes, it's quite useful to use them for the forest inventory issues as well. So before going to the main objective of the research, I would like to show where we came from, where we are working. We are working in Yoshkar-Ola at Volga State University of Technology. And the last 10 years, we are doing a lot of in the field of remote sensing and GIS, especially in forestry. Speaking about this area, it's also should be mentioned 2 big cities, Nizhny Novgorod and Kazan. Maybe you have heard about these cities last month, since championship takes place in these 2 big cities.
We are not there. But
No. We are between.
We are not there.
We are between. I mean, Yoshkar is between these 2 big cities as well. So distance to Moscow is 800 kilometers. And these 2 big cities are in between. If to look on the modest color image, you can see that it's quite heavily forested area. About 60% is covered by forest. But today we will be talking about this area. It's Penza region, which is forest steppe region. This is Volga River, one of the biggest rivers in Russia, flown in Caspian Sea. Okay. On the map of Russia, it is like this. It's Penza region. And we took as example 2 districts, two forest districts on the territory of Yursovo and Leninsky forest districts in the Penza region. Objective of this research was to assess the suitability of using Sentinel-2 images for mapping 3 species, which again is quite important for the forest inventory issues. And also to distinguish between forest strata on the example of forest stands in Penza region of 2 forest districts. In order to support classification and compare the forest species, we took huge 2 big campaign during 2016 and 2017 between June and August in the forest districts in order to collect field data, which is quite important, as you know, to verify the classification results. Test sites with an area of at least 10 to 10 meters for the validation of thematic mapping were selected along transects to present the full range of the main land cover classes and species typically occurring in these ecosystems. It is, as you know, it's a very hard job to stay two months in the forest and to collect this data. It's a very hard job. So, but it's very important for validation. We have all equipment with us to measure the trees, to measure the diameter of the trees, the height of the trees. And main species were birch, Quercus robur, Scotch pine, Pinus sylvestris. And this is this table with sample plots. All in all, it was about 300 sample plots with different areas, and a number of forest polygons with total pixels of about 70,000 pixels. The area of the test site was at least half of the hectare in order to find it on the Sentinel-2 images. Estimation of forest stands were carried out using the forest inventory methods of ground-based measurements for each test sites, and to calculate the composition, height of the tree, and so forth and so on. For the classification, we used this Sentinel data. It was decided to use summer and autumn images in order to compare them and to see what happens during the phenological changes. And for distinguishing between the classes, we used Jeffrey-Matsushita algorithm, distance algorithm, for the separability of the classes of region of interests. And it shows quite good results, as you see, since the minimum point should be 1.41 according to the classical understanding, but it was higher. Most of the results were higher, and sometimes even 2. So we used 10 classes for classification. We managed to distinguish between pine forests, only between pine forests in terms of age. We distinguished middle-aged, it's 41 and 60 years according to Russian classification, and higher, 81, 120. So this is under mature and then mature and over mature stands. Birch, which is Betula pendula, 61, 80 years, medium and high density. Usually it's first or third class of bonitet, according to the German foresters. Aspen, Populus tremula, also in the age of mature, 41, 60 years. Tilia cordata, lime trees, under mature 40, 60 years and mature 61, 80 years, but we combined them in one class. We couldn't distinguish, unfortunately. Or Quercus robur, middle-aged and again mature stands. Young stands, we couldn't distinguish between conifers and broadleaf species. That's why we combined them in one big class, just young plantations, up to 40 years. Alder, Alnus incana, sometimes Alnus nigra, also over mature and over mature stands. Bearlands, as usual, and moisture boggy places, which is quite big area in this territory. We used supervised classification, maximum likelihood, which is quite popular, and it usually gives the best results for the classification using these 10 classes. And validation or accuracy shows that the classification accuracy was 81% and kappa statistics 0.76. The decrease in accuracy we have found only in young forests, which was quite difficult to distinguish, and also in birch stands. Comparing two graphs of summer and autumn images, it was very important to see that there are quite clear separation. So sometimes it's better to use autumn images, not September or beginning of October. That time is quite good, especially for broadleaf species when they starting to turn into the leaves going from green to yellow. So this time it's very good to distinguish between, for example, birch and alnus, or Tilia cordata and Populus tremulus species. This is quite important for forest inventory issues. In conclusion, the results of the research shows that Sentinel-2 imagery could further strongly support activities of forest inventory and mapping for forest classifications in this region, not only in this region, but all over Russia. For forest classification images acquired earlier, end of spring, and later, beginning of autumn, lead to higher classification accuracies. In the case of the tree species classification, however, it was difficult to identify and classify mixed forest stands. That's why we were using pure stands beginning of seven, for example, 7 trees out of 10. So this is, we didn't consider them as mixed stands, but pure stands. And therefore, in our study, we used combined series of Canopus. Canopus 5 is a Russian satellite, which has quite high resolution. For some cases, for validation, we used the satellite as well. The classification algorithms have to be chosen according to the forest cover characteristics. We have chosen maximum likelihood algorithm for flat area, whereas the forest cover features were with clear spectral behavior. The resulted forest cover maps have a high level of detail as they are produced from Sentinel images at 10-meter resolution. And finally, the four spectral bands, the training sets, and classification algorithms represent key factors for the forest and tree species map production. And using multiple spectral bands from Sentinel images acquired in the 2 seasons improved the accuracy of the classification at the spectral separability between tree species. It increases. Thank you very much.
Okay, we have time for 1 or 2 questions, please.
Yeah, you have mentioned that you use the Landsat data before for similar purposes. Do you have an idea or have you done any kind of study to compare the results with the 2 different satellites?
You mean, do I know some results?
Yeah, if you did some similar classifications before with Landsat.
Yeah, we started with Landsat, but sometimes Landsat is also very useful. It's also very useful, especially for the ML classifications, and we sometimes distinguish between different classes as well. But Sentinel is quite higher, of course, very high.
Are there any additional questions? Okay, we can thank you.